Hello, my name is Mema Rajapulu, and I am the project coordinator for the Horizon 2020 NEANIAS project entitled Novel EOSC Services for Emerging Atmosphere, Underwater, and Space Challenges. In this presentation, I will provide a brief overview of the NEANIAS project, its objectives, and our planned activities. The overall goal of NEANIAS is to promote open science practices and play an active role in the materialization of the EOSC ecosystem by engaging large scientific and professional communities and actively contributing to the technological, procedural, strategic, and business development of the European Open Science Cloud. NEANIAS will drive the co-design and delivery of innovative thematic services derived from state-of-the-art research assets and practices in three major sectors: underwater research, atmospheric research, and space research. Each of these engages a diverse range of academic and business groups, numerous researchers, professionals, and governmental entities. By providing sustainable, innovative services, we aim to achieve the following specific objectives. First, we will address community-specific needs for underwater, atmosphere, and space research sectors. We will onboard communities to the European Open Science Cloud and interdisciplinary research era. We will nurture new business opportunities, and we will power up the European Open Science Cloud. Our consortium consists of a diverse set of 20+ partners, including academic universities, research institutes, and SMEs from a wide range of countries. This picture is a nice summary of the entire project. We see here our three thematic areas, which engage a wide and diverse set of communities. We are co-designing with these communities innovative thematic services, and we'll be integrating these services into the European Open Science Cloud by exploiting existing EOSC services and the EU Open Science ecosystem. We are engaging user communities and will lay out a viable business plan for the services we will be deploying to enable their sustainability. Through our NEANIAS Innovation Hub, we will identify new actors and business opportunities in the energy and smart city domains, as well as others. And we will do this by engaging SMEs and industry, researchers, and government stakeholders, both as potential producers and potential consumers of the NEANIAS services we are deploying. Each of these sectors engages a broad set of communities. For example, in underwater domain, we see underwater archaeologists, geologists, as well as geohazards experts, as well as insurance companies who want to be informed about geohazard events. In the atmospheric sector, we have a diverse set of user communities, from geologists and urban air quality authorities, to civil protection authorities, to insurance and healthcare providers. In the space sector, again, a broad range of user communities, from astrophysics scientists and planetary scientists to space weather experts and engineers. Now, if we look at each of these research sectors, we'll see that each has their own set of challenges and needs. For example, in the underwater research domain, bathymetry mapping, here, the current state of the art, requires expert users using open science software that needs adept use and is not user-friendly. In the underwater, in seafloor image mosaicing, the challenge is that data is captured under widely varying conditions with different lighting apparatus, different levels of terrain roughness, with the presence of refracted light. All of these things affect the quality of the outcome and make mosaicing challenging. In seabed classification, at present, the state-of-the-art involves experts indicating manually regions that train supervised algorithms. And they need to do this for every single region of interest, which is time-consuming. In the atmosphere domain, we have massive amounts of data that are being gathered, and there's a need for monitoring greenhouse gas flux density, for estimating the concentration of gas and particulates in active tectonic volcanic regions, and for measuring air quality effectively. Unfortunately, there are currently no standardized or open source implementations of algorithms. Instead, there are many duplicate versions that have been developed by isolated teams, which makes collaboration and following open science principles a challenge. In the space sector, we have sky surveys that are composed of two-dimensional, three-dimensional, or data cube tiles for a limited portion of the sky. This limits our understanding of objects and events that extend over multiple portions of the sky. As a result, we cannot have a large-scale view of a particular phenomenon, and thus we need tailored services that map and mosaic data for scientific exploration in a way that preserves the native characteristics of the data. There is also a need to integrate machine learning techniques for the automatic detection of structures in large-scale multidimensional maps. Now, if we can deploy services that address the challenges in each of these research sectors, and we integrate these services into the European Open Science Cloud successfully, then this enables several business opportunities to flourish. For example, if we can perform seabed classification successfully, then this would be of great interest to energy power companies that need to lay down cables on the seafloor. If we can do air quality monitoring efficiently, then this is of interest to urban planners and real estate, people in real estate, to agriculture productivity, and even to healthcare providers who may, for example, want to apply preventative measures in hospitals to respond to citizens' needs. And in the space sector, if we can provide the missing tools for efficient and scalable visual discovery and virtual reality, then this may be of great interest to national space agencies, space museums, planetariums, which may be interested in this for educational purposes. In the underwater research, for the underwater research sector, we have a work package that's dedicated to this, to the implementation of three specific services, the deployment of three specific services, the bathymetry mapping from acoustic data service, the seafloor mosaicing from optical data service, and the seabed classification from multispectral multi-beam data service. In the atmospheric research sector, the services we will deploy include the greenhouse gas flux density monitoring service, the atmospheric perturbations and components monitoring service, and the air quality estimation monitoring and forecasting service. And in the space sector, the three services we'll be deploying are the Fair Data Management and Visualization Service, the Map Making and Mosaicing of Multidimensional Space Images Service, and the Structural Detection on Large-Scale Maps with Machine Learning Service. As I mentioned earlier, a key aspect of the NEANIAS project is to identify viable business cases that arise out of deploying the services in each of the research sectors. We've identified two specific business cases. One is in energy, where the idea is to exploit atmosphere data on wind elements and extreme phenomena to facilitate the operation of wind turbines. The second case is in environmental monitoring for smart cities. Specifically, the goal here is to perform air quality estimation, monitoring, and forecasting for smart city operation. Besides these two specific cases, we aim to identify other new ideas and to trigger business innovation around NEANIAS services via open innovation calls for external research and industry entities, via datathons and hackathons as introduction points for young researchers and entrepreneurs. And all of this to be done within the context of our NEANIAS Innovation Hub. Another important aspect of the project is the deployment of what we call core reusable services. We are performing a top-down analysis starting from thematic service requirements in order to identify reusable parts of the services, as well as those ingredients that are needed to integrate with the European Open Science Cloud Hub. The idea is that some of these reusable parts can form components for future new services, and thus the goal is to deliver reusable cross-sector services that are generic yet able to specialize to case-specific needs. In particular, we're developing 4 core reusable services. These are the Open Science Lifecycle Support Service that enables integration with the EOSC Hub, allowing providers of services to publish information about their services and users to locate resources as well as to validate data sets associated with or used by these services. The next reusable service is the EOSC Integration Service, which enables other NEANIAS services to access and consume infrastructure resources such as storage, computation, and data. The AI service provides a reusable substrate for machine learning and other AI algorithms that may be of use to NEANIAS users and services. And the visualization service provides both two-dimensional, three-dimensional, multi-dimensional spatial temporal visual rendering and support for virtual and augmented reality. Here we see the technology stack that we're building in the NEANIAS project. We have our thematic services on top, in the top layer, 3 services per research sector. We have our reusable core services, and all the thematic services are built on top of the core services, which in turn are built on top of and with the help of in-place EOSC research infrastructure services such as the EOSC Hub Marketplace, the portal, Beta Store, and so forth. We have a work package dedicated to EOSC integration, where we are monitoring the EOSC landscape and its evolution to identify existing services in the European Open Science Cloud that can be used in NEANIAS use cases and in the thematic services we're deploying. Our aim is to ensure that NEANIAS service development is fully aligned with the different components of the EOSC ecosystem, including the portal, the catalog, the marketplace. And to work with the EOSC onboarding team to perform all necessary validation checks. Are we at the appropriate TRL? Is there a service level agreement in place? Are we doing service provisioning, service pricing, and so forth? We have a work package dedicated to developing an assessment methodology to determine what's required in order to achieve sustainability of service offerings beyond the 3-year duration of the project. We will perform market analysis to draft business models that identify target markets, key actors, revenue streams, cost drivers. We'll perform sustainability analysis of the proposed business models to evaluate their viability and identify any bottlenecks in service offerings. We will perform a legal and ethical issues analysis, okay? And this is to help us establish a governance model for NEANIAS. Our project has a strong orientation to industry and business with 5 SME partners and 2 enterprise partners. In this final slide, we see the list of work packages of the project. Besides the first management work package, we see the 3 work packages 2, 3, and 4 dedicated for each of the 3 thematic areas: underwater, atmosphere, and space research. We see work package 5 dedicated for business innovation. Work package 6 is for the reusable core services implementation and deployment that I mentioned. Here we also have a work package 7, which is for service delivery, where We provide instruments and processes for the efficient delivery of quality software, for the assessment and the evaluation of our NEANIAS services from a technical perspective, for training people to onboard and use the EOSC services. Work Package 8 is for EOSC Integration. Work Package 9 for assessment and sustainability of the NEANIAS service offerings beyond the duration of the project. And of course, there is Work Package 10, very important for communication, dissemination, and outreach. We aim to maximize the visibility of the project's work and its achievements. We will engage stakeholders that can support sustainability of the project, and we provide essential information on the NEANIAS project to third parties, especially those in the Horizon 2020 and European Open Science Cloud landscape. This concludes our overview of the NEANIAS project. For more information, please check out our website and online social media presence in the links listed here. We'd love to hear from you if you have any questions or comments. Thank you.